Hello, I'm Carly McAvoy, and today I'm doing part 3 of the Math 141 prep. 141 is our pre-calculus class at South Puget Sound Community College. And so I wanted to show you how to solve a compound inequality. The compound inequality could be an or an and statement. This one is or. So we're looking for something where x could fit the first scenario or it could fit the second scenario. So it's a union of the two parts. I'm going to just simplify or solve both of these inequalities. I have negative 4x and I subtract 4 from both sides. I get 4, and if I divide both sides by negative 4, remember when you divide an inequality by a negative, you reverse the direction of the arrow to keep that to be a true statement. Now if I was to look at the graph of this, I have negative 1. I don't have an equal to part. X is less than that, so I'm looking at a parentheses or an open circle, depending on how you graph it. Something like that would be the graph of that one piece. Now let's look at this one. If I want to solve this, I'm going to move 4x to the other side, even though I like to keep the variable on the left side, so I'm going to do that. So I get negative 6x, and I'm subtracting 18 from both sides, is greater than negative 18. And if I divide both sides by negative 6, again, I've divided by a negative, so I want to reverse the direction of the arrow, and I get x is less than 3. Now, what does that look like? Well, I have 3, and it's, again, no equal to part. So I have a rounded or a parentheses going to the left. What I want to do for my final answer is graph these two parts onto one graph. Well, if you think about it, if you look at the number line, here's negative 1, over here is 3. If I already have a piece that's going forever to the left, I don't need to show this piece because it's already going to be covered. Everything to the left of 3 is covered here. And since I'm not looking for an overlap, I'm looking for a union, like all parts covered. So I am just going to the left from 3, but not including 3 because I did not have an equal to part there. If I did, I'd use a bracket, an equal to part, a greater than equal to, or less than equal to. I would use a bracket to show those, right? But I don't have a bracket because I don't have an equal to part. Okay, totally switching gears here. Let's take a look at this one. This is an equation with a radical in it. What I want to do is take that to the second power, but first I want to move that 6 to the other side. So I'm going to get the square root of negative x plus 8 is equal to x minus 6. I'm subtracting 6 so that I get that radical alone. So I'm going to square this side, and if I square this side, I need to remember to square it as a binomial. This square root to the second power is negative x plus 8. What happens over here? It's not x squared plus 36. Remember, you have to FOIL it, so you actually get x squared minus 12x plus 36. That's the FOIL that you should be familiar with from your previous algebra experience. Now if I move everything to one side because I have a quadratic and I want to factor or use the quadratic equation or whatever I need to do to solve this, I'm going to move everything to the other side. I get 0 equals 3x squared minus 12x. 36 minus 8 is 28. 28. Oh, what did I do here? I had x and I added it to my x squared, so I don't want to do that. And I wouldn't have gotten 3x squared there anyway. I don't know. It is late. I need to stop working on this. I'm going to add x here, and that's going to give me 11x. Sorry. So I have x. I have a negative x. I added x to both sides. I can only add it to a like term, which is the same variable to the same power. And I'm going to subtract 8 from the like term over here, and now I get this. I don't know what was happening there, but anyways. Let's factor this. I have x squared, which is going to go to x and x. 28 is going to go to 4 and 7, and they're both going to be negative so that when I multiply them, I get positive. Going back to the 0 property of equality, I know that I set each of those pieces equal to 0 and get my two possible answers. This was minus, so I'm going to add 7 and get 7. Now, want to check to see if one of those is extraneous or one of those is not really a true solution. Let's take the 4. Negative 4 plus 8 would be square root of 8. So I'd have, square root of 4. Negative 4 plus 8 is 4. Square root of 4 plus 6 should be equal to 4. Well, that's actually 2 plus 6, which does not equal 4. So 4 doesn't actually work, even though we found a solution. When you square something like this, it's possible to generate an extraneous solution. That's why you want to check it. Okay, then I'm going to go back and try the 7. Negative 7 plus 1 would be the square root of 1, plus 6 should equal 7, which is our x, and that equals 7 equals 7. That does check out. So our answer is 7. 4 is extraneous. Again, here's where I made a mistake earlier. We don't want that. We want to just factor x squared minus 11x plus 28. You get two solutions, one of which is extraneous and one of which is an actual solution. All right, and the last one here, number 13, I'm going to add 3 to both sides to get this radical by itself. And then I want to get rid of this cubic root. And so what I want to do is take that to the third power. And if I take the left to the third power, I need to take the right to the third power. And when I take a cubic root is actually to the 1/3 power. So that's like saying I have a 1/3 power and I'm taking that whole thing to the third power, and a third of 3 is 1, and that's how I just get the radicand 4x minus 69. Okay, you want this index to match that power to cancel them out. So 3 to the third power is 27. I'm going to add 69 to both sides. 9 and 7 is 16, and 6, 7, 8, 9. And now divide both sides by 4. And 4 goes into 9 twice, with 16 left over, 24. All right, so x equals 24. We can check that by just taking the 24, plugging it in. 4 times 24 minus 69, and the cubic root of that. All right, that is part 3. I just want to mention that as I worked through this problem, I had an error. But if you work math enough, you're going to find out you're not going to be perfect. You will make mistakes. You will have errors. Now, if I was doing this in front of a class, somebody would have pointed that out to me as soon as I did it. When you're working alone, sometimes it takes a little longer. Making a mistake does not mean that you're bad at math. Maybe you're hurrying like I was, or maybe you just space out for a second. That doesn't mean you're bad at math. If you stick with it and you find your mistakes, you learn from those mistakes. That doesn't mean you should stop if you make mistakes. It means you just need to persevere a little bit.